population proportion. Okay, so let us first talk about proportion. So what is proportion? Okay, let us assume that we are considering one class of having 60 students, right? So let's say this is the number of students that we have. The number of samples altogether in a class is about 60 students. And you would like to know the proportion of female students in the class. For example, in the case of this one, in the case of what we have here, we have 30 male students and 30 female students. Okay, for 30 male students and 30 female students, we can try to find out the proportion, the sample proportion for the female in that class, right? So how are we going to do this? Okay, the formula is given as P hat equals to X over N. What is X? X is actually what we call as the number of success. Okay, what is the number of success? The number of success is actually referring to the case or the things that we are referring or we are trying to describe. For example, we are trying now to describe about the proportion of female in this class. Okay, so we are going to use the number of successes which is referring to the number of female in that class. How many of all the students? Out of 60, we have about 30 students of female. Okay, so we'll be having X over N, which is X is the number of success and N is the total number of the whole sample, right? So this is going to be 30 over 60, right? 30 over 60. Why is it 30? 30 is the number of success, which is the number of female students that we are talking about just now, and 60 is the number of sample on the whole, right? So when you simplify this one, you can actually calculate it is actually 1 over 2 or equivalent to 0.5, and when we try to put it as percentage, it is actually equivalent to 50%. Okay, so when you want to relate proportion and percentage, you can actually try to relate by multiplying it with 100%. Okay, so 0.5 proportion is actually equivalent to 50%. Okay, for this case, you can straight away see actually we have half of them. Half of them are female and the half of them are actually the male students. Okay, so that's why it is 50%. Okay, so that is what we have for proportion, right? So in the case of confidence interval, we are going to estimate the proportion for the whole population. Now this is just the case of a sample, right? So in order for us to find out the proportion for the sample, the proportion for the whole population, which is pi is the population proportion, we'll be using a quite similar formula that we have before, which is P hat plus minus Z and square root of P hat times 1 minus P hat over N. Right, look at the formula that we have here. Okay, in the case of proportion, we have to make sure that the sample that we have are large enough, which is N is equals or bigger than 30 samples. Right, so N will always be in the size of bigger or equal to 30 samples. So this is going to be for all the time we have to check that the size have to be more or equal to 30. So that's the reason why in the formula of pi here, we have only Z in the formula. We don't have the case of T for the part of proportion for the whole population. Okay, so pi, which is the proportion for the whole population, will be equals to P hat plus minus Z multiplied by the whole thing here, right? So what are the things that we have in the formula? Again, we have the value of Z. The value of Z that we are going to use are the same value that we have before, which is we are going to depend on the level of confidence that we have. Okay, if you are trying to find the level of confidence which is 90%, 90% level of confidence is equivalent to 1.65. 95% level of confidence is equivalent to 1.96, the value of Z, and 99% level of confidence will be equals to 2.58. Okay, this is actually the way of writing the Z value, right? So after you identify the value of Z, you can straight away substitute in that formula of Y that we have here. Okay, the rest of the things are quite similar as before, which is N is still the number of sample. The new one is going to be the P hat. Okay, so what is P hat? P hat is actually the proportion for the sample. So we estimate the population parameter, population proportion, by using the sample statistics, which are related to the sample proportion, Z value, and the sample size, right? This is the example from the module. Okay, exercise 5A, question number 5, right? Suppose that a random sample of 100 people are interviewed in a large metropolitan area, and 65 of them indicate they are in favor of a particular federal program, right? So find the 95% confidence interval for estimating the proportion of all people in metropolitan area that are in favor of the program. Okay, so in this scenario given to us, we have about how many samples? We have 100 samples. Okay, and you are having the information of 65 of the 100 samples are in favor of a particular federal program, and find 95% confidence interval to estimate the proportion, okay, proportion of all people in that metropolitan area that are in favor of the program. Okay, so these are the information that we have here. The underlined one would be the important points that we'll be using. Okay, we have 95% confidence interval. So that's why 95% level of confidence, the value of Z that we will be using is 1.96. Okay, we can check that the number of sample is actually equivalent to 100. Okay, 100, right? 100. The whole number of sample is 100, and 65 of 100 people who are in favor of a particular federal program. Alright. So we have 65 over 100 to find out the P hat, which is the sample proportion. So we get 0.65 for the sample proportion. Okay, 0.65 for the sample proportion. Okay. So when we substitute into the formula of this one, we have P hat of 0.65, we have Z value of 1.96. The rest is P hat, and N is 100. Okay, this is the place where students normally wrongly substitute the value. Okay, you have to remember that the sample size is 100. It is not 65. 65 is the number of success. Okay, so make sure that you put the right value for N. Okay, N is the number of sample, the whole sample that you have. Okay, so when we have done with the substitution in the formula, you'll be calculating by using the calculator, and this is what you get, 0.56 and 0.74. Okay, so if you want to change it into percentage, it will be around 56 to 74%. Okay, you can say that 56 to 74% of the whole people in the metropolitan area are in favor of the particular federal program. Okay, so that is one way of interpreting, or you can also use the method that we have before, which is I am 95% confident that the proportion of all people in the metropolitan area that are in favor of the program is between 0.56 and 0.74. Okay, so that is another way of interpreting.